All right, good afternoon. Today I'm going to be reviewing your test on last Friday. Some of you chose not to complete your test, resulting in a grade of a 0. Some of you completed your test and you had some incomplete problems. You didn't have work or explanations. You all know my one motto. And your grades just weren't too good. So I'm going to review this test, and then after I review this test, you will have an opportunity to get started on your retest. With that retest, make sure you're paying attention to what you're doing. First of all, make sure you have some work and that you're using your notes and information that you received on last week. You will have until this Friday to complete your retest. All right, number 1. It asks, which of the following numbers are perfect squares? A perfect square is a number that's multiplied twice. And if you had your chart with you, you should have easily picked out B, C, E, and F. B, 6 times 6. C, 9 times 9. E, 11 times 11. And F, 13 times 13. So I said if you had your little chart with you that we drew on last Monday, you should have did well with these perfect squares. Number 2 said, tell whether each equation is true or false. Once again, if all you're doing is looking at something, that's not good enough. You definitely need to be trying to see if you can solve it. All right, looking at A. Cube root of 60, they say will be 20. But if we do 20 times 20 times 20, we clearly will not get 60. So that is false. All right, B had the cube root of 64 is equal to the square root of 16. Both of those should have been in your chart. The cube root of 64 is 4. And then the square root of 16 is also 4. So that would have been true. All right, C, we got 25 is equal to the cube root of 125. When the cube root of 125 is 5. So clearly that is false. For D, we got 12 is equal to the square root of 144. The square root of 144 is 12, so that would be true. And then E, you should have separated that. So that would have been the square root of 4 divided by the square root of 9. Both of those should have been in your chart to give you 2/3. The right side had the cube roots. So you should have found the cube root of 8 and then the cube root of 27. Once again, they both should have been in your chart, and that would have been 2/3, and that would be true. All right, number 3. It reads, which expressions have a value between 7 and 8? Between 7 and 8. So we can look at C, D, and E first and look at square roots. 7 squared is equal to 49 and 8 squared is equal to 64. So if they fall in that range, it will work. So that looks like B and it looks like E. And then up top, you could have estimated that pi out to be what it is. So about 2 times 3.14 would give us about 6.28, and that's less than 7. We could have tried B. It would be about 3.14 plus 4, which would give us 7.14, which would work as well. So you should have came up with B, D, and E. Four. It says, how can a decimal 12 repeat be expressed as a fraction? On last week, we learned that you look at the last decimal place. This last decimal place is the hundreds. And then after we find that place, we will take away 1 from that place. So 100 minus 1 will be 99. The digits that repeat will then be the numerator. And then, of course, we simplify. 12 and 99, I can clearly see that they both can be divided by 3. 12 divided by 3 is 4. 99 divided by 3 is 33. So you should have came up with 4 23. All right, number 5 said, consider these numbers. And then wants to know if they were rational or irrational. Before you can tell something about something, you got to know some vocabulary. Rational numbers are any numbers that can be written as a fraction. And then irrational are any numbers that cannot be written as a fraction. first we got square root of 3, 8. If I would separate that, I would get the square root of 3 and the square root of 8. And neither one of those is the perfect square. So that means square root of 3/8 would be irrational. You would say not a perfect square. All right, we got 0.75 repeat. Now the last problem, we wrote a repeated decimal as a fraction. So that means this will be a rational number. All right, we got the square root of 1/16. We can separate that as the square root of 1, square root of 16, square root of 1 is 1, square root of 16 is 4. Since we were able to get an answer for that, that would be rational. Or in other words, it is a perfect square. All right, next they gave us 3.8. 3.8 is a terminating decimal, and terminating decimals are rational. Those are decimals that stop. All right, we got -12/7. It's already a fraction, so that should be an indicator that it is rational. All right, we got the square root of 10. It shouldn't be on your chart, so it would be irrational because it's not a perfect square. And last but not least, we got pi over 2. We learned on last week that anything have a symbol will be irrational. Anytime they give us a symbol for pi, it's irrational. All right, 6. It reads, which of the following lists the numbers in order from least to greatest? Least to greatest. All right, so you should have came on the side and played with your numbers. All right, some of us went ahead and solved square root of 34, which was fine. You could have went ahead and did that. And that would have gave you about 5.83. We had 6 and then 2 pi. We can estimate pi to be 3.14. So that'll give us about 6.28. And then you could have found the square root of 42, which is about 6.48. Correct answer would be D. Once again, notice that I didn't just look. So definitely make sure that you are putting forth some effort and actually trying with these problems. That's the only way you're going to learn math. All right, it says the red tablecloth has a diagonal of the square root of 10 feet. The blue tablecloth has a diagonal of the square root of 30 feet. Aaron says that the length of the diagonal of the blue tablecloth is 3 times the length of the diagonal of the red tablecloth. Is he correct? He said blue is 3 times red. So let's figure out what he said. Square root of 10 times 3 will get us to 30. And that is a false statement. He multiplied 3 by 10 to get 30. Square root of 10 will be less than 3. No, a little bit greater than 3. So square root of 9 is 3. And square root of 30 will be less than 6. Tasha's bedroom is shaped like a square. The room has an area of 169 feet. What's the length of one side? And then they told you to show your work. When I tell you to show it, we need it. So the formula for area of a square is A is equal to S squared. The area they gave us was 169, which is equal to S squared. We should have learned to get rid of a square. We take the square root. So then the square root of 169 would be 13. And that should be on your chart. But they said show your work. So we needed to see that piece where you're showing us you found the square root of 169, or you could have told us 13 times 13 is 169. So the value was 13. But you definitely should have had some work with it. All right, the next one says simplify 3 to the second to the fifth. This is a power by a power. And those integer exponents told us that we would multiply these exponents. Power by power, we multiply. 2 times 5 will give us 10. And the exponent remains the same of 3. Says consider the number 0.19 repeat. He said write 0.19 repeat as a fraction. Same process as earlier. 19 is in the hundreds place. Take away 1 from that value and we'll get 99. And then 19 would be on top. 19 and 99 does not have anything in common. Part B of that asks us, is this value rational or irrational? And we would note that it is rational because we were able to change to a fraction. All right, the next one said, look at the equations below and tell whether each statement is true or false. Once again, do not rely on just looking. Make sure we're able to determine why. A, we are dividing with the same base. I'm gonna write the rule at the bottom. And anytime we are dividing with the same base, we subtract exponents. So then that would be 9 minus a negative 5. Don't forget that. See, I put that negative value. We could then rewrite that as 9 plus 5, which would give us 14. So this statement was true. All right, B is using a power by a power. We just learned we multiply those exponents. Zero times 3 would be 3. So then 5 to the 0 power. And then we learned another rule. 0 exponents equal 1 whole. Not 1 as an exponent, but 1 whole. So that would be false. All right, C, we got 4 to the 5th times 2 to the 5th. This will be multiplying with the same base. And when we multiply with the same base, we multiply the numbers and the exponents stay the same. So in this example, 4 times 2 will give us 8, and we should still have that exponent of 5. So that will be false. And then D. D is multiplying with the same base. Anytime we multiply with the same base, we add exponents. So then it will be negative 9 plus 7, which will give us negative 2. So 3 to the negative second power. We then have a rule with negative exponents. Negative exponents take the reciprocal, meaning flip, and the exponent becomes positive. Take the reciprocal, and the exponent becomes positive. So right now we have 3 to the negative second power. 3 is the whole number, so it will be over 1. So when we take the reciprocal, it's moving to the bottom. And instead of a negative 2, it's a positive 2. So that one will be true. All right, the next one says simplify 12 to the 0 power. So it told me that it equals to 1 and reminded me that 0 exponents solve to get 1. Some of you said it solved to be 12 to the 1 power. So that's why I tell you, make sure you pay attention to it. Any exponent of 0 will not be rewritten as that. It'll just be 1. All right, the next one said, consider these numbers. We got the square root of 10, 3.16 repeat, pi, and 3.2. The first one said, recognize numbers that are rational. Rational numbers are repeated decimals and any standard decimal. So you could have said 3.2. It's a terminating decimal. And then notice it told you to explain. Some of you didn't do your explanations. And then you should have said 3.16 repeat because it is a repeated decimal. B asks which ones are irrational. Pi. And you should have said because it is a symbol. And then square root of 10 because it's not a perfect square. We won't get a hold on it. The third part of that then said label the number line and graph the approximate location of each number. Since all these values will pretty much be 3. Let's start with 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, and then 4.0. All right, 3.2 will clearly be here. 3.16 repeat will be right before it. And then pi, we understand pi to be approximately 3.14. So it will be in this part as well. And then we got the square root of 10. Square root of 10 we know would be greater than 3. Or you could have went ahead and placed that in the calculator and saw what you got, which is about 3.16. So it will be in that same space. So then all 3 close together, or really will depend on how you drew your number line. All right, the last one, it asks which expressions are equivalent to 5 to the 18th power? All right, so once again, we got to remember those integer exponent rules. First rule, multiplying with the same base, so we will add exponents. 9 plus 2 is 11, so that will be 5 to the 11th power, which is not 5 to the 18th. B, they are dividing with the same base, so we will subtract exponents. 24 minus 16 is 18, so that could be rewritten as 5 to the 18th power, which would work. C, multiplying with the same base, add exponents. 12 plus 6 is 18, so we can rewrite that as 5 to the 18th power, and yes, it will work. B had 5 to the negative 18th power, and we should already know that would not be the same. We would have to move it on the bottom, take the reciprocal, and put it over 1. E gave us a power by power, so we will multiply those exponents, and that would have gave us 5 to the 77th power. So we should add B and C as correct answer. All right, after you view this video, after you view this video, definitely make sure you do your retest, take your time, show your work, do your best. And then after you do your retest, write those answer choices down on a quick piece of paper and then put them in case.